Very good morning, dear children. Today in mathematics, we are going to continue chapter number 3, LCM, HCF and LCM, the third part. In the third part, we are going to learn to find out HCF using prime factor method. So let us recall greatest common divisor, that is highest common factor. We are familiar with HCF and LCM of positive integers. Let us learn something more about them. The HCF or the GCD of the given number is the greatest common divisor or factor. So let us learn now using prime factor method. So we have a number called number 24 and 32 here. So yesterday only we have learned how to do the prime factor. So we are going to take a prime factor of 24, okay, first. So the 24 factor is 2 12s are 24, 2 6 are 12, 2 3s are 6 and 3 1s are 3. Therefore, the prime factor of 24 is 2 into 2 into 2 into 3. Now, next we are going to do the prime factor of 32. The 32 is the prime factor of 32. So, I'm sorry, the factorization, we are going to do the factorization of 32 number. So, 2 16s are 32, 2 8s are 16, 2 4s are 8 and 2 2s are 4, last is 2 1s are 2. Therefore, the factors are 2 into 2 into 2 into 2. Children, this is horizontal method, okay, which this side, okay. This is vertical method and horizontal. Yesterday only we have learned both the methods. So they have solved in both the methods, okay. Now we are going to find what are the common factors here. So here also there is a 2, here also there is a 2. 2, 2, 2, 2. So here 3 2 is common, here also 3 2 is common. So the common factor for 2 occurs how many times? Thrice. Therefore, the HCF is 2 multiply 2 multiply 2, that is 8. Therefore, the factor, the HCF of 24 and 32 is what? 8. This is the normal method, okay, to find out the highest common factor. Now, I know if one of the given number is the divisor of all the others, then it is HCF of the given number. If no prime number is a common divisor of all the given numbers, then one is their HCF because it is the only common divisor. Something more. 2 is the HCF of any two consecutive even number and 1 is the HCF of any two consecutive odd numbers. We can verify this rule, okay? Now let us solve practice set 12. So we have two numbers here, 25 and 40. Now first we will solve using a horizontal method, okay? So 25 is a divisor of 5 into 5. Now let us solve for 40. So 40 can be written as 5 into 8. That is 5 8s are 40, right? Now this 8 can be factorized as 5. We will be carry out. This 8 can be written as 2 into 4. 2 into 4. Further, if we see, children, this 5 will be carried out, 2 again. Now this 4 can be written as 2 into 2. This we have learned yesterday itself, right? So we have factorized all the number 25 and 40. Now we have to see, this is a factorize of 25 and 40, right? Now we have to find what are the common factor among 25 and 40. Okay, what is the common number between 25 and 40? One is 5, it's already underlined. Here also 5. Any other number is common here and here? No, only 5. So I'm sorry. So the common factor is what? 5. Therefore, HCF is what? 5. Dear children, are you getting? See, this is the horizontal arrangement method. Now I'm going to solve in vertical method. Okay. So we are having 25 and 40 is the question. First we have to see both the numbers should be divisible in a common number. Okay, the 25 is also divisible by 5 table, 40 is also a divisible of 5 table. So I will write here 5. So 25 is divisible by 5. So 5 5s are 25, 5 8s are 40. Further, we have to check whether this 5 and 8 are divisible in any other table. 5 is divisible in 5 table, but 8 is not divisible in 5 table. So here we will stop the factor. So here we have only 5 here. Therefore the HCF is what? Therefore the HCF is what? 5. Okay. One more example. Now we have 3 numbers here. Okay. One is 40, another is 60, another is 75. So first we will write the factor of 40. Okay. Using horizontal. So 40 can be written as 5 8s are 40. The 8 to be factorized, right? So let us factorize. The 8 can be written as 2 into 4. 2 into 4. Now the further 4 can be factorized as 2 into 2. Now 40 has been factorized. Now what is the next number? 60. Let us factorize the 60. 60 can be written as 5 12s are. Now 12 to be factorized, right? 12 can be factorized as 2 into 6. 12 can be factorized as 2 into 6. Now 6 can be factorized as 2 into 3. Don't think that where did this 5 and 2? We are just carrying from the further step. Okay. Now 75. 75 can be factorized as 5 into 15. 5 15s are. Now 15 to be factorized. This 15 can be written as 5 into 3. 5 into 3. Right, children? Now further it cannot be factorized because all the numbers are even prime numbers. Now let us see among this 3 factorization which is a common factor among these 3 numbers. Okay. So first we will see the 5 is there here also, here. Any other number 2, here 2 is there, here also 2 is there, but in 75 there is any 2? No, there is no, there is, 1 minute. Here we have common factor 2. Here we have, but in 75 we didn't have any common factor 2. So our common factor is what? The common factor is what, children? 5 is a common factor. Therefore the HCF is what, children? The HCF is 5. So we have done with the horizontal arrangement. So now let us try it in the vertical arrangement. Okay, children? So we have 3 numbers, 40, 60 and 75. All the numbers, if you see the unit place, children, 0, 0 and 5. If we have the number ending with 0 and 5, it is divisible by which table? 5 table. So this all 3 numbers are divisible in 5 table. So we will divide by 5. So I will write here 5. So if I divide, I'll get a quotient as 8. If I divide, I'll get the quotient as 12. If I divide, I'll get a quotient as 15. Further, let us see whether it can be factorized. Okay, 8 is divisible in 2 table, 12 is divisible in 2 table, but 15 is not divisible in 2 table. So leave it. So further, it cannot be factorized, children. So I'll stop here. So here, therefore, our HCF is what, children? HCF is 5. Okay. Now, we will solve one more example. So now we have 3 numbers here, 18, 32 and 48. First, we will do the vertical arrangement. Sorry, horizontal arrangement. So we have 18 here. 18 can be written as 2 into 9. So 9 can be further factorized as 3 into 3. I hope, children, you are getting now. 32. 32b can be factorized as 2 into 16. Now the 16 to be factorized, the 16 can be factorized as 2 into 8, right? 2 into 8. Now 8 has to be factorized. 8 is factorized as 2 into 4. Now this 4 to be factorized, as 2 into 2. Now we have 48. Let us factorize 48. 2 into 24. 24 is factorized as 2 into 12. This 12 can be factorized as 2 into 6. 6 can be factorized as 2 into 3. See, children, this will be a better understanding, children. If you do this way also, no problem. Okay. If you have any confusion, you can put an arrow mark and you can solve like this. So now let us see what is the common factors among these 3 numbers. Okay. So I have already underlined, children. So here, what is the common number here? Common factor. The common factor is 2. See, it has been already underlined. Therefore, the common factor is 2. Therefore, answer is what? HCF is 2. Okay. Now let us learn the vertical arrangement. So 18, we have 18, 32 and 48. So 18, all 3 numbers is divisible by 2 tables. So I am going to divide by 2. So 2 9s are 18, 2 16s are 32, 2 24s are 48. This 9 is divisible only by 3 table, but this 16 is not divisible by 3 table. We will stop it here. 24. All the 3 numbers should be divisible in the common number. So here 9 and 24 is divisible by 3 table, but 16 doesn't comes in the 3 table. So we will stop it here. Therefore our HCF is what, children? 2. One more, children. 57, 75 and 102. So let us write the horizontal arrangement. So 57 can be written as 13 into 19. 3 into 19. This 19 cannot be further factorized because 19 itself a prime number. When we do a factorization, we have to factorize until we get a prime number. The first step itself, we got a prime number, so we will not do we cannot do further prime factorization. 17 can be written as 5 into 15. This 15 can be further factorized as, children? 5 3s are 15, right? Okay. So now 102 be factorized. 102 be factorized as 2 into 51. This 51 can be factorized as 3 into 17. Okay. 17 cannot be further factorized. So our common number, what is our common factor here? 3, 3, 3. Therefore HCF is what, children? 3. This is horizontal arrangement. Vertical arrangement. All the three numbers is divisible by 3 tables. So 3 9s, 19s are 57, 3 25s are 75, 3 34s are 102. If you are finding difficult, how did you get this? Divide whatever the quotient comes, you have to write it here. Okay, divide by 57 divided by 3, I'll get a quotient as 19. 75 divided by 3, I'll get answer as 25. 102 divided by 3, I'll get answer as 34. So further it cannot be divided because the 19 table is a prime number. It will be divisible only by its own table 19, but 19 in 25 doesn't comes in the 19 table, and 34 also. So we will stop here itself. So our answer is what? HCF is 3. The last sum I am going to solve, children. 777, that is 777, 315, 588. So I am going to do 7 into 111. 111 can be further factorized as 3 into 37. 37 will stop here itself. So 315 can be written as 5 into 63. 63 is further it is divisible in 3 tables. So we will write it. We can write it like this. Okay. 7 table also it comes. It can be, we can write 3 table also. Anything is fine, children. This 9 can be factorized as 3 into 3. Now 588. 88. So it is divisible in 2 table. 2 into 294. 294 is further factorized as 2 into 147. 147 can be factorized as 3 into 49. 49 is divisible in 7 table, children. So 7 sevens are 49. What is the common factor among these 3? 7 is there in all the 3 factor, right, children? Yes. Now again 3 is there in all the number. So our common factor is what, children? 3 and 7 is the common factor. Therefore our HCF is what? 3 sevens are how much? 21. Therefore HCF is what? 21. So let us solve in vertical arrangement. Okay. So 777, 315 and 588. All three numbers are divisible 7 table. Okay. So when I divide, I'll get a quotient as 111. When I divide 7, when I divide 7 into 777, I'll get 111. 7 into 315, I'll get 45. 7 into 588, I'll get 84. Now all these 3 numbers are divisible by 3 tables. So when I divide, I'll get 37, 15 and 28. The common factor is what? 3, 7 and 3. Therefore 7 3s are 21. The HCF is how much? 21. So dear children, this is a 2 method for solving HCF. Okay, one is vertical arrangement, another is horizontal arrangement. Whichever you find it easy, follow that. I prefer practice both the methods. Practice both the methods because further if we move to the next exercise, both the methods you are going to use further. So when you practice also, dear children, when you write it in the notebook also, you are supposed to write both the methods in the notebooks. But in the examination, you can write any method. If it is not specified. If teacher specifies that solve using vertical arrangement, solve using horizontal method, so accordingly you have to solve. If it is not mentioned in the exam, you can solve any one method, either horizontal method or vertical method. Okay. So but in the notebooks you are supposed to write both the methods in the notebook. Okay, as I solve here in the same manner. So shall we move to the next sum? Okay. Now question number 2. Find the HCF of the division. Find the HCF by the division method. By the division method, I have to find the HCF. And reduce the simplest form. Reduce the simplest form. What is the question here? 275 divided by 525. Now how to solve this? Using division method. This method is called as a division method, and reducing into the simplest form. By reducing, this is the easiest way of reducing the simplest form, that is cancellation, children. Like this we do now. Yes, cancel and we solve it, right? That way. So this is the simplest and the easiest method, okay, to reduce division method. By this method we can also find the highest common factor. Okay, first step. What is the first step, children? We have to divide bigger number by smaller number. So what is the bigger number here among these two? 525. I will write it inside. 525 inside. Please, when I speak, children, please notify my cursor. Okay, see the screen. 525, bigger number by smaller number. Smaller number, I will write it inside. Normally when we divide, we write the quotient up, right? Now in this method we will write the quotient in the right hand side. Okay, first I am going to divide here. Again I am telling, I'll divide bigger number by smaller number. So bigger number I will write inside, smaller number I will write outside. So when I divide 525 divided by 275. So I'll divide. Ones are 275. When I subtract, I'll get 250 here. Now this will be my divisor. Okay, dividend. I'll take this 275. Okay, 275 as a divisor here. 275 inside. When I divide, 250 ones are 250. I'll divide 25. This will become, I will divide by, where did I get that 250? From the previous, 1 minute, from the previous divisor. Okay, from the previous divisor, 250. 25 tens are 250, 0. Now we have the last divisor, right? Okay, I will divide until I get remainder as 0. I will divide until I get answer as 0. Okay, I will take the previous divisor and I will divide. So now I will get last, what I got, a divisor as 25. Therefore our HCF is what, children? Our HCF is 25. Shall we solve one more sum? It's very simple. Don't get confused. Okay. One more sum. 76 divided by 133. So what is the first thing you have to remember? I will divide the bigger number by smaller number. Okay, bigger number by smaller number. So I'll write bigger number inside. 133 divided by 76. When we divide, normally we will write quotient in the quotient up, but we will write in the side. Okay, so 76 ones are normal division. So we get 57 when I subtract. So I'll take the previous divisor here, 76. I will write it here, this number I will write it here. Okay, and when I again divide by 57. So when I divide, say 57 ones are 57 and I divide, I'll get 19 here. Now I'll take the previous divisor. Previous divisor is 57. Okay, so previous divisor is 57. Previous divisor is 57. Now I'll divide. So 19 3s are 57. I'll divide until I'll get 0. Right, children? I said, right? I said until we should get until we get 0, we have to divide with the previous divisor. So what is the last answer we got? 19. Therefore our HCF is what, children? Our HCF is 19. This is the simplest way of reducing the terms and also to finding the HCF. I hope, dear children, you would have understood what teacher had taught you. You will solve this. First, you will look onto the video very carefully. If you are not understanding, again listen and see the video. Write it down in a solve this all the sums of this practice set in a neat and clean handwriting. Again, I'm telling, when you're finding HCF, you will write both the method vertical as well as horizontal arrangement in your notebook in a neat and clean handwriting. If any doubts, you can ask. Any other thing? Thank you. God bless you all.